Good morning, class. Welcome to Maths Grade 11. This is our sixth session together. You are with Miss Shabalala again today. Remember, you guys can contact me on Twitter. My handle is @_Mbaliti. Missed you guys yesterday. I had a bit of technical difficulty, but we're back today and we're here to get the ball rolling. Welcome to everyone and thank you for joining me on this slightly chilly morning. We are still well within trigonometry. I'm so happy that you got a chance to revise everything yesterday and we are moving forward today. Just a few things from me. Our rules of engagement. Number 1, we're going to respect each other because we're all here to learn. Number 2, there's no such thing as a dumb question, so please ask. Number 3, please type your questions in the Q&A section. Number 4, all questions will be in the Q&A section will be answered in the last 10 minutes. So as you know, now that we have moved to Teams, we do not have a verbal interaction, but I will ask you to please leave your questions in the Q&A section and I will address those in the last 10 minutes. Also, what I need from you guys, please, is when you do ask a question, please ask your questions with reference to a particular question or slide. So please give a bit of context around what you are asking so that we can address that accordingly. Next up, we will not tolerate vulgarity. This is particularly in the Q&A section and in the chat section, guys. It goes back to number 1, please let's respect each other. Next, please don't take the opportunity to learn away from someone else. Someone else might be really interested. Please don't refer to anybody's question as dumb. Please don't block anyone from any opportunities. Lastly, the link to the lesson will be posted in the Q&A session for your perusal, guys. Thanks again for joining me today. So, first things first, I have an announcement to make. If you've been following our class, you are expecting that we will be doing double angles and half angles today. Guess what? Double angles and half angles will be done next year in grade 12. And so that's been moved out to next year's syllabus. Looking forward to challenging you guys, but we're going to catch on to double and half angles here and there, just in a different way. All right, so what are we doing today? We are jumping onto trigonometric equations. Today's lesson in particular is around the revision of the concepts that you learned in grade 10 around trigonometric equations. We're going to look to be finding angles, how to find lengths, how to find lengths, how to find angles, and also how to solve simple trigonometric equations. Once we've got this nip in the bud, we'll pick up tomorrow and we'll be running with trigonometric equations. Right, guys, so far since we've started our classes and our interactions, we focused a lot on right angles. And with our right angles, we've learned about special angles. So we've done the 30, 60, 90 right angle triangle, and we've done our 45, 45. This should be 90 right angle. And so we've also found out that if you have angles and you're looking for a side, we use the Pythagorean theory. What we know about the Pythagorean theory is that you need to have a right angle and you need to have 2 sides that are available. So, for today's lesson, we are talking through what happens if you don't have a right angle, or what happens if you only have one side. How then do you go about solving for the length of the side or the angle that you're looking for? That basically is where we are working when we're talking trigonometric functions. This is the overarching principle that we will delve into over the days. Right, trigonometric equations is how you get this done. So first we're going to start with finding lengths. So here we have a right angled triangle with a 90-degree angle and a 50-degree angle. We've got side A and we have the hypotenuse, which is 100. So normally we would have been given side A as an amount or a value, or would have been given the opposing side and we would be told to look for A, in which instance we would apply the Pythagorean formula. When finding the angle in this particular instance, it would be quite easy because we know that it would be our 180 minus the 90 minus the 50. And we could easily get 40. So, but here's today's scope, and I'm saying to you, please find me the value of side A. How would you go about finding side A? When we talk about equations, guys, we're talking about a left-hand side and a right-hand side. We normally use equations when we have an unknown variable, but we have a relation to that variable on the other side of the equal sign. By relation, I mean to say that on the other side of the equal to sign, you have a method, a way in which, an understanding in which how the other side would have been arrived at. So let's see, we need the length of side A today. But we can't use Pythagoras because we do not have two sides. What do we do now? We apply our trigonometric equations. Simply put, we're going to say the sine, we're going to use sine because sine of theta, this is our theta, our alpha, sine of alpha, this is our alpha. Sine of alpha is equal to opposite over hypotenuse. We are looking for the opposite length, right? We're going to then from here fill in our known variables in our equation. Remember, this is an equation. We have a left-hand side, an equal to sign, and a right-hand side. In an equation, I'm saying to you that one side gives you a relation for how the other side works. So at the moment, we are looking for an opposite side. What we do know about the opposite side is that you can include it in a sine calculation and you have an hypotenuse. So this is what we look like when we've substituted. We have the sine of 50 degrees. A is your opposing angle. 100 is your hypotenuse right there. And we do our usual multiplication when it comes to equations. What you do on the left, you do on the right. So we multiply this side by 100 and we multiply this side by 100 as well. And that leaves us looking something like this. 100 sine 50 degrees is equal to A. I generally like to swap them around such that the unknown variable sits on the left side of the equation. But I'm sure it's not a train smash. From here, bring out our calculators, bam, bam, bam. The length of side A is 76.66. Let's call it centimeters. We didn't give a measurement. Let's call it centimeters. Something we tend to make mistakes around, guys. It's a weird mistake. When we talk length, when we talk size, right? We are talking meters, centimeters, kilometers, literally length as proposed. And then when we're talking your alphas, your betas, when we're talking angles, we are simply talking degrees, x degrees, y degrees. So this number, I'm thinking about it because when you look at the size of this A, for example, could easily mistake this for a degrees, which it isn't. It's centimeters. Right, this is our first example, and in our example we've used sine because we were looking for an opposite length. Right. So we apply trigonometric functions to find lengths where Pythagoras cannot be applied. And when can Pythagoras not be applied? If it's not a right angle with two available sides, then Pythagoras cannot be applied. Here we have our second example around finding lengths. Here we have a right angle triangle again with a 25-degree angle. We have a hypotenuse of 7, let's call it centimeters as well. And we have a side G, and we do not have any other side. And so in this particular case, we are going to use the cos rule, cos of alpha. Why are we using cos? Our 25 is the alpha. This is the angle that we're looking for, and this is the side that we're solving for. So this side is adjacent to the angle that we are working with, and that is why we're using adjacent, and we have the hypotenuse available over hypotenuse. Remember the rule when it comes to solving equations and you have a fractioned view or a divided view, it's always your unknown variable over your known variable. So even when you are looking to set up your equation or looking to find out which function you should be using, it's always best to use unknown over known. So if, for example, this was 7 and this was G, you know that you have the adjacent angle available, and you are looking for the hypotenuse. So your unknown is the hypotenuse, hypotenuse, and you have the adjacent side available. When we look at our functions, which function speaks to hypotenuse over adjacent side? It is your sec. That's how we basically do this. It's always your unknown over your known. Right, from here we have our adjacent. We substitute now our known variables. We have adjacent, which is our unknown, over hypotenuse, which is known. And our alpha here is 25. Again, we do what we normally do, multiply, or what we do on the left, we do on the right. Multiply by 7 to get rid of the denominator. So we have G is equal to 7 cos of 25. Pull out our calculators, bam, bam, bam. And G is equal to 6.34 centimeters. So what can you tell me about what the steps are about how to go about finding a length? Number one, you determine which side we're looking for. So in this particular case, which side are we looking for? We're looking for side G. We need to look at where is that side relative to the given angle. The given angle is 25 and side G is adjacent to the given angle. In which side is given relative to the angle? In this particular instance, we've been given the hypotenuse. And so already you can hear the alarm bell in there around which function to use. You're looking for an adjacent and you have a hypotenuse. Remember the unknown over the known rule, and easily, therefore, what function should you use? And that becomes cos. This is our last example around length, guys. Hope you're keeping up. Remember, give me your questions in our Q&A. The example that we've just done is basically example 2 under finding lengths. That's the reference that you will use when you need to ask a question about that. Right, so here is our third triangle, and we are applying the same method of finding length. We are going to be looking for side J. Here is a difference to what we've been seeing. So in our last two examples, I've been giving you a hypotenuse. There is no hypotenuse in this case, but here we have our 42, which is usually our alpha, and this is our J, which we're looking for. Right? The 4 questions that I've just given to you, we can follow those in an orderly fashion. Let's see, which side are we looking for? We are looking for side J. Right? Where is the side relative to the given angle? Side J is adjacent to 42 degrees. right? Which side is given relative to the angle? We have been given the opposite side relative to that. And so what relation are we looking for? Adjacent over opposite. What is adjacent over opposite? If you remember, guys, we remember functions and we remember cofunctions. It is cot. So when you state your working example, you have cot alpha over adjacent over opposite, and you substitute everything as you should. Again, your unknown over your known. Here, cot being what do you refer to? A cofunction. We've changed it to tan and we've switched that around as well because cot is the same as 1 over tan. We've updated that and we are going to solve for J. When we solve for J in this particular instance, again, we follow the steps. What you do on the left, you do on the right. We've multiplied by J. And then again, what you do on the left, you do on the right. We multiply by the tan of 42. And we will use our calculator to get J. Bam, bam, bam. J is 8.885 centimeters. And that, guys, is how you get that angle. That's how you get the side. There's always a way to do a small sense check. For example, here we have a 42 and we have a 90. So by default, we know that this is a 48 degrees. With this being a 48 degrees, this side here should be bigger. This side here, the opposing side here, length, should be bigger than this side's length because the angle follows the size. So from a relative perspective, 90 is our biggest angle and our hypotenuse is our longest side. Then whatever the bigger angle is, that side will be longer. And so to get 8.885 for this side makes sense given that this angle is bigger than this angle and 8.885 is bigger than this side. Just a small sense check that I use. Right? We've done the lengths, quite straightforward, quite simple. And now we're going to look into finding angles. Finding angles is easy when you have two other angles given to you because you know that you have your angles of a triangle adding up to 180 minus whatever side that you're given to you. So in this particular case, we don't have any other angle given to us other than the 90-degree angle. And so we need to solve for beta. Here we have two known sides. Remember, the sides also speak to the relationship of the angles. The longer side has a higher angle, or the bigger angle has the opposing bigger angle. Just always keep that in mind as your sense check. So here we have two lengths, and how do we calculate angle beta? Angle beta is calculated using the trig formulas as well. We have an opposite side and we have an adjacent side. That is why we are using sine. So the sine of beta is equal to opposite over hypotenuse. Right? We're going to substitute again our known values, just like that. And in our calculator, we are going to put in sine to the power of -1 times 0.8. And that will give us the value of angle beta. Angle beta comes in at a 53.13 degrees. Ladies and gentlemen, I hope you're happy with that. I hope you understand how that works. This you may refer to either as example number 4, or you may refer to as example number 1 of finding angles if you have a question. Right? Again, we follow the same methodology. Which angle were we looking for? We were looking for beta. Which sides have been given to us relative to the angle? We were given two sides. We were given an opposite side and a hypotenuse. and already that tells you which function we are looking to use. Which function we'll be using then? We'll be using sine. That is the methodology, guys, or the sequence for finding angles. Next up, here's our second example. We will be looking for alpha. So let's try by following our methodology. Which angle are we looking for? We are looking for alpha. Which sides relative to alpha have we been given? We have been given the opposite to alpha. We have also been given the side that is adjacent to alpha. When we have opposite and we have adjacent, sound, you should be hearing that the function we are looking for is tan. And then, ladies and gentlemen, you do your relevant equation, where you're going to say that the tan of alpha is equal to the opposite side over the adjacent side, which is your 30 over your 40. Pull out your calculator, tan to the power of -1 times 0.75, or even 30 over 40, or 3 over 4, however you put it. Bam, your answer for alpha is 36.87 degrees rounded off. It's really that simple. Apologies for this, guys. This should read angle. And this, guys, is the methodology for finding angles. Any questions on this, please refer to this as either example 2 of finding angles or example 5 across. Right, solving trigonometric equations. We've used a technique where we've been seeing the triangle, and so it's been easier to resolve. So what do we do when we don't see the triangle? We apply the same methodology. It's really simple. So you will be given something like this, 3 sine A, and your angle is A. So you are looking for A. This one is quite simple because you know what sine is, but number one, let's start by keeping the left side at what we are looking for. Sine A, what you do on the left, you do on the right. Sine A is equal to 2.4 over 3. You calculate 2.4 over 3 and you put it in the calculator. You say sine to the power of -1. And then in brackets, you'll put your 2.4 over 3. And you have your value for A. So we don't see a triangle. We don't see the size of the triangle. But what we can tell is, if not exactly, then to this scale, our opposite and our hypotenuse angle have a 2.4 to 3 relationship. So I've set up a few examples for homework for you guys. These are the examples that we will do first thing tomorrow before we continue with the lesson. Just basic examples to get you back in the groove of trigonometric equations. Guys, I'll give you some time to write those down. And while you're writing those down, the angle we are looking for here is B. The angle we're looking for here is C. Right. I'll just make a few announcements. Firstly, guys, yes, I would like to say sincere apologies for not coming through yesterday. I had technical difficulty, as mentioned. As you know, guys, we've moved to Teams now, so please, if you can, share the link with your friends. I'd like to do as far reach as possible for grade 11 maths. I'd like to assist you guys as far as I can and hope that we can grow together. Right? From here, guys, this is your homework for tomorrow. We'll do a quick recap on what these are. As always, I've always put up the links for you guys. I'm very big on Siyavula and very big on the Khan Academy. The Khan Academy has really nice quizzes. Some quizzes are quick and short where they just need an answer, and some can give you time to work out. Please look at these. Please refer back to the Siyavula textbook. We use the Siyavula textbook in our lessons, and so if you have any questions or if you need points of reference to go back to, that textbook is a great place to go and visit. Right? I've put in grade 11 and I've put in grade 10. Grade 10 for the revision purpose, and grade 11 for you to see where we're going for the rest of our lessons on trig equations. Quick recap, what we've done today is we've revised our grade 10 trigonometry. We now know how to find lengths, we now know how to find angles, and we know how to solve simple trigonometric equations. What are we doing tomorrow? We'll be going through our homework questions, and we're going to be solving more advanced trigonometric equations. Do me a favor, guys, tomorrow, don't forget to bring your calculators, right? I will be taking questions if there are any questions in the Q&A section. Q&A, there we go, Q&A. I see there are no questions in the Q&A section. I'll take for granted that it means we've done well and everybody absolutely understands everything that we've done today. If not, remember, don't be shy. You're welcome to contact me via Twitter. _Mbali T is my handle. And this is everything around African Geeks is here for your perusal, guys. Whether you need the links, whether you need additional information, whether you're looking to find out what other classes are available or even the timetables, these are all your hashtags and your handles that you can look to visit. Thank you again for being with me today, guys. As always, take good care of yourselves, keep to your religious regime, drink your water, keep your peace of mind. See you all tomorrow morning. Bye. Okay, guys, we seem to have a question that has just popped up on our Q&A. Okay. And I just lost the question. Our question says, what if they don't give you any angle except for a 90-degree and one side? How then would you go about solving for alpha? So remember when I said to you in an equation, you have to have a relatable relationship. So if they give you one side only and they give you one angle only, you are not able to determine a relationship on what the alpha could be in that case, what the alpha possibly could be in that case. So I'm very tempted to say to you, because I mean, think of it this way, when we talk about a right angle, from your learning of Pythagoras, you think there's Pythagorean triplets. So there could be multiple combos for what the other sides could be. It is unlikely, well, it does not make sense. You will not be given a case where you only have one right angle and one side. You have to either have one side or one angle to be able to work with that. If you're looking for an angle, you will be given two sides, because you need to see how those two sides relate to the given angle, so you can determine the relationship of how they relate to your angle that you are looking for. I hope that answers your question. Let's see. There we go. Yes, here's our call, guys. Yes, I hope that answers your question. Cheers, guys.